I'm start. Hello, it's a pleasure for me to be here. My name is Ekin Cansu Özkan. I am working on the Turkey's biggest construction machine firm Hidromek, and today I'm gonna make a presentation about development of a blade lifting control assist system for a motor grader. And at the end of the presentation, I would love to answer your questions if you have any. Today's contents will be scope and motivation, literature survey, methodology and development, and then I will talk about controller design, grading control algorithm, and finally results, conclusion, and feature work. Motor grader is the construction machine which is used in road construction, snow plowing, and leveling works. The blade is a permanent component to perform the machine functions. And in traditional motor graders, the operator tries to set the desired height level using the joystick. And sometimes for the operator, it is challenging because it is challenging both drive the machine and control the blade. So the study scope is to develop a control assist system for grading purposes for a motor grader. And our motivations are importance of leveling accuracy, savings on time and operating costs, and increasing productivity of operator. When we look at the literature, we saw that there are limited documents about the motor graders, compounds on the other construction machines like excavators and wheel loaders, but the studies have been guide for us, and the main focus on these studies were to control the machine operations actually. And motor grader blade mechanism has 6 hydraulic cylinders and a hydraulic motor. And you can see the axis orientations with the for the blade movement with the movement of the hydraulic equipments. The mechanism, the motor grader blade mechanism has different orientations, and to control the level, the focus point is to control the lifting cylinders actually. So for the mechanism analysis, we make some limitations for the blade mechanism as written here. And we use 3D CAD program tools to find the relationship between the lifting cylinder stroke values and the blade edge positions. And finally, we use least square regression method to find to express with an equation this relationship. And to test the mechanism analysis equation, we implement two-wire encoders through the lifting cylinders, and the wire is directly connected to cylinder rods. So when the cylinder moves, the encoders gives directly millimeter value, and this means the actual stroke value. And with this test, we sure about the mechanism analysis equations for the lifting. In traditional way, the operator try to set the in traditional way. The operator use the joystick for the up and down movement of the blade. And the joystick movement has a joystick value in percent, and actually the joystick value has a certain current value. And this figure, this graph is from supplier, and the joystick value, and according to the produced current, the PID controller runs, and then hydraulic valve and hydraulic cylinder activated respectively. To understand the motor grader blade mechanism hydraulics, we used system identification method. What we have done, we enter the system, the desired level for the blade, and then the equations that we found on the mechanism analysis calculates the desired stroke values for the desired height, and then using the input-output relationship, we found some transfer functions of the lifting cylinders hydraulics, and then we solve some delays, and the electronics or hydraulics can cause the delays. So firstly, we want to check the electronics, and then we check the PWM current and joystick value graphs, and we saw that the electronics has a has a quick response, but for the hydraulics, there is a time needed to fill the hydraulic liquid to the cylinder or return to the tank. And these two graphs shows two different joystick values. And you can see from here, the behavior is similar, but with the higher joystick value, there is an irregularity. And then we want to see the cylinder velocities for 3 different joystick values, and we choose these like slow, medium, and fast joystick values. And you can see from the table there is no common ratios between them. So we want to plot the all joystick value and all cylinder velocities graph, and we saw that there is an linear behavior up to 30% joystick value. And this means that the controller to be created can be activated for a certain stroke level up to 30% joystick value. And now for the grading control algorithm, we use 2 controllers, feedforward and feedback. For a certain level for the lifting strokes value, the feedforward controller runs with a certain joystick value like 30%. And now for the precise control, the PI controller runs. And this is decided by the switch block, and the plant block represent the characteristics of the electrohydraulic valve. And finally, we test the grading control algorithm on the test machine, and on the test machine for the different key P values. And from here, the key P value is 2.5, and both right and left lifting cylinders, the key P value, when the key P value is 2.5, the precise position control for the stroke is 3 mm was achieved. And to sum up, with this study, we provide parallel lifting control for the motor grader blade, and we propose mechanism analysis for a complex mechanism, and the control algorithm was created for all engine speeds. And in future work, we want to make controller for the different mechanism positions, and we want to add additional sensors to the machine for different terrain conditions and mechanism positions. And these are the author's contact details. And thank you.